7. Welcome to our first lesson on forensic chemistry and its role in the criminal justice system. In this introductory session, we'll explore what forensic chemistry is and how it helps solve crimes. Forensic chemistry is the application of scientific methods and principles to analyze physical evidence found at crime scenes. The insights gained from forensic chemistry analysis can be crucial in building criminal cases and achieving justice. Over the next few slides, we will dive into the key techniques and technologies used by forensic chemists, as well as some real-world case studies. I'm excited to share this fascinating field with you and demonstrate how forensic chemistry is an essential tool for law enforcement. So what is forensic chemistry? If we're going to talk about the definition, forensic chemistry is the application of chemistry to criminal and civil law cases. Now, it involves analyzing evidence to solve legal problems scientifically. Now, our goal is to provide scientific evidence that is admissible in court proceedings. Forensic chemists play a crucial role in the justice system by using their expertise to uncover the truth and support legal decision making. The work of forensic chemists can range from analyzing trace evidence to identifying unknown substances, all with the aim of shedding light on the facts of a case. Forensic toxicology has a long and storied history, dating back to the pioneering work of Matthew Orfila in the early 19th century. Orfila is considered the father of toxicology for his groundbreaking research on detecting arsenic poisoning. We also have Theodore Wormley in 1867. Theodore Wormley made important advances in microcrystalline testing for alkaloids. He expanded the field's analytical capabilities. Modern forensic toxicology now utilizes sophisticated tools like chromatography, spectroscopy, and DNA analysis to identify and quantify a wide range of substances. Legal standards like the Fry and Daubert rulings have also shaped the admissibility of toxicological evidence in court. This historical progression demonstrates the steady evolution and increasing sophistication of forensic toxicology over the past 2 years. Forensic chemistry is a critical field that helps solve crimes and uncover the truth. The core principles we'll cover today provide the foundation of reliable scientific analysis of evidence. First, we have the Lockhardt's exchange principle. The Lockhardt's exchange principle by Edmund Lockhart states that every contact leaves a trace that can be analyzed. This means even the smallest pieces of evidence can provide valuable clues about what happened. Next, we have the chain of custody. Now, the chain of custody ensures evidence is handled securely and, of course, documented at every step. This is because we have to protect the integrity of the evidence and maintain its admissibility in court. We will also discuss analytical methods, both quantitative and qualitative techniques used to identify substances. Those rigorous scientific approaches allow us to draw accurate conclusions from the evidence. Finally, quality assurance. Validating methods and regularly testing proficiency is critical. This quality control ensures the reliability and credibility of forensic analysis. As forensic experts, we play a critical role in the criminal justice systems through our work in evidence analysis, crime scene investigation, expert testimony, and ensuring legal standards are met. Our primary responsibility is the identification and quantification of chemical substances found at crime scenes. This provides crucial information to investigators and prosecutors. We also carefully collect and preserve physical evidence from crime scenes, ensuring it can be properly analyzed and presented in court. When called upon, we communicate our scientific findings clearly and, of course, effectively as expert witnesses, helping the court understand the significance of the evidence. Importantly, we also ensure the evidence we present meets the necessary legal standards for admissibility, such as the Daubert rule, so that it can be properly considered. Our work is essential in upholding the integrity of the criminal justice process and helping to deliver fair and accurate outcomes. This slide covers the different types of evidence that our forensic lab analyzes, including controlled substances, trace evidence, arson debris, explosives, and toxicological samples. For controlled substances, we look at illegal drugs and pharmaceuticals. Trace evidence includes fibers, hair, paint, and glass fragments. When investigating arson, we detect flammable liquids and accelerants in the debris. For explosives, we analyze residues and device components. Toxicological samples like blood and urine are tested for drugs and poisons. These are the key areas of focus for our forensic analysis work. Let's now talk about some common analytical techniques, and one of that is our GCMS. So GCMS is a powerful analytical technique used to identify drugs and accelerants used in arson cases. Liquid chromatography, on the other hand, allows us to analyze non-volatile compounds that cannot be detected using gas chromatography. Spectroscopy technique like UV-Vis and IR provide valuable information about the chemical structure and composition of compounds. Microscopy enables us to conduct detailed examinations of fibers, hair, and other trace evidence. ICP-MS, which is one or the last common analytical technique used in forensic chemistry, is an extremely sensitive method that can detect trace elements at minute levels, which is crucial for certain forensic applications. Let's go over to a case study 1, which is drug identification. So this case study examines a forensic investigation into a white powder found at a crime scene. Now we can use presumptive tests to identify what is this white powder, but in the lab, we can actually use an analysis, and that is your GCMS. So as a confirmatory test, we can have GCMS to confirm the presence of cocaine, which is a powerful and illegal stimulant drug. The scientific evidence provides strong support for drug trafficking charges against the suspect. And so the detailed chemical analysis and identification of the substance was a critical part of building the legal case. This demonstrates the important role that forensic science can play in gathering evidence and supporting criminal prosecutions. Now, for our case study too, which is an arson investigation, this case study focuses on an investigation into a suspected arson at a warehouse. Now, the scenario is that a warehouse fire was suspected to be caused by arson. The only way to figure this out is to do a confirmatory test. Now, you can only do a confirmatory test if you're going to use GCMS. Okay? So GCMS can detect the presence of gasoline accelerant residues, providing key forensic evidence. Now, based on this analysis, the evidence supports bringing arson charges against a suspect. So for the legal impact, forensic findings will be crucial in building the case against the suspected arsonist. Now, in summary, we only have two key points here. Forensic chemistry is a critical field that enables accurate analysis of evidence, which is essential for ensuring fair and just legal outcomes. Our forensic experts used advanced scientific techniques and equipment to meticulously examine physical evidence, ensuring that the findings are reliable and can withstand scrutiny in a court of law. Providing clear, well-supported expert testimony is crucial for upholding legal standards and reaching appropriate conclusions in criminal and civil cases. Our team is highly trained to present complex technical information in a way that is understandable and compelling to judges and juries. By combining the expertise in forensic chemistry with other fields, we can commit in delivering reliable testimony. We play a vital role in the justice system, helping to protect the rights of all parties and ensure that the truth prevails.